Welcome, physics students. Yeah, there's math and physics. And in this case, in lesson 4, we're going to deal with vectors. So we're going to go back to our Algebra 2. And if you haven't had Algebra 2, it is introduced in Algebra 1 a little bit, but we really get into it in Algebra 2. So let's talk about vectors and resultants for just a moment. This is just a refresher. If you have not had it, please let me know and I can go into more detail about how to do this mathematically for you. So we're dealing with vectors. We're dealing with the coordinate system. And that just means a graph like this. We have this, and then we have this, right? We have the x-axis, and then we have the y-axis, and we have the 4 quadrants. So a vector always starts here when we give the answer in resultant form or in what we call polar coordinates. It always starts here, and then wherever it ends is our length. And that length is going to be written here. Then you have a slash mark. And then the degree of measure relative to the x-axis here, the terminal axis, is given here, and it's in degree form. So let me illustrate what that means. Let's say that you have a problem in this worksheet where you go to north. So let's go to north. This is our starting point. 1, 2, north would be up. If you look at this like a compass, north, south, east, and west, you could look at it like that. So 2 north, and then afterwards you go 4 meters west. So 1, 2, 3, 4. So you'd end up here, right? So that would be 1, 2, 1, 2, 3, 4, right? So that would be a straight line from here to your starting point. That would be like that. Well, the way that we find out the degree of measure for that is we treat it like it is a right triangle. And we find the length of this hypotenuse. And the way we find the length of the hypotenuse is we get the dimensions of our right triangle. And we know that it's 2 tall because we went up 2, and it's 4 wide because we went over 4 from the origin. So 2 and 4. Those are the legs of our triangle. We don't really need this anymore. That's just where we traveled to get here, to get to that point. Okay, so this is our vector. This is where we ended up. So we're going to use what's called SOHCAHTOA, which is sine, cosine, and tangent, to find the degree of the angle here. In order to find that, we need to find the hypotenuse. And the way we find the hypotenuse is with Pythagorean's theorem. So Pythagorean's theorem, we talked about him a little bit. His theorem says that with a right triangle, and this is a right triangle because we drew a line straight down and this made a 90-degree angle to the axis, you have a squared plus b squared is equal to c squared. And those are the sides relative to each other. A and B are the perpendicular sides, the sides that make the 90-degree. And then C is the hypotenuse. It's the slanty part between the 2 perpendicular sides. So 2 squared is 4, right? And then that's going to be, 4 is the other one. 4 squared is 16. So that equals c squared. We don't know what c squared is yet. So we're going to add these together. That's 20 is equal to c squared. We'll have to get rid of the c squared. Basic math, we undo the square by unsquaring everything. So that cancels the c squared. But now we're left with 20, square root of 20. Now in algebra, we taught you to just simplify it to where you would pull out the factors. That would be 4 times 5. And we can get the square root of 4, which is 2. So 2 times the square root of 5 is where most of us would have stopped in algebra. But in physics, we want to finish the problem. We want to go ahead and finish the calculation. So we don't have to do the mental math. Instead, all you have to do is get to this point and then put it in your handy dandy trusty calculator like you've wanted to do since the beginning of algebra. Type in 20, hit the square root button, and it gives you the answer. Now we're going to typically round this to 1 decimal place. So we can round this to 1 decimal place by rounding the 4 up to 5 because of this 7 right here. So this is going to be 4.5, and this was in meters, so this is meters. That is C. So this is 4.5 meters. That is our length. So that length goes here, 4.5. Okay? And in algebra, we didn't use the unit of measure, but here we're going to use the unit of measure, 4.5 meters. So now that we know the length of the distance from the beginning point to the ending point, which is the hypotenuse of this right triangle, we put that in here. Now we can use that to help us find this degree of measure here. So this degree of measure, we have something called SOHCAHTOA, which helps us remember how to use the sine, cosine, and tangent. And that is trigonometry, for those of you who don't know. And that trigonometry, it tells us the relationship. It can help us find the degree of measure. So we remember what this little acronym means. This is the sine. Sine is equal to opposite over hypotenuse. And this is the hypotenuse. And what it means by opposite is the side opposite the angle. This is the angle, so the side opposite the angle would be 2. We have that dimension, so we can use sine to find the degree of measure. Cosine would be the adjacent over the hypotenuse. This is A and H. And tangent would equal the opposite over the adjacent. So if you didn't have your hypotenuse, you could use the opposite angle, which would be 2, or the opposite side, which would be 2, over the adjacent. And the adjacent just means the side that helps make the angle. That is not the hypotenuse. So the side that helps make the angle is 4. So 4 is our adjacent. 2 is the side that is opposite the angle. The angle points to that side. But we have everything here, so we're just going to use sine. The sine of, we don't know what this is, so we're going to call it x degrees, is equal to 2 over 4.5, because that is our opposite side over the hypotenuse degree, or the hypotenuse length. So now we're just going to use our calculator. We don't have to do the math in our head. God made calculators for a reason. So 2, just like it looks right here, divided by 4.5 is equal to 0.44444, right? So that does not round up. We're not going to write the answer to it just yet, because what we want to do is find the degree of measure. So to find the degree of measure, we have got to use the inverse sign. So we're going to hit the second, and we're going to use the sign to the -1. That means inverse sign. That's when you don't have the degree of measure. We use the inverse. So we hit the inverse button, and we get 26.387 degrees. Well, this will just round up to 26.4. So let's just use 26.4. That's going to be a whole lot easier. Right? So x degrees is equal to 26.4 degrees. That is our degree of measure right here. But we cannot write 26.4 because we have this whole quadrant to think about. It's not just from here. We have to think about think about radar. We have to think about the whole sweep of the field. So we start measuring from here. This is 90 degrees, this is 90 degrees, this is 90 degrees, and this is 90 degrees. All 4 of those is 360 degrees. That's a whole circle, right? So we have to tell where this line is located on the whole circle. And we always start measuring here. So we know from here to here is 90, here to here is 90. That's 180. A straight line is 180 degrees, if you remember that from algebra or geometry. So what we have to do is subtract 26.4 from this whole sweep of 180 to find out where exactly this stops. Okay, like a clock can going backwards. So 180 minus 26.4 is equal to, and just do that on the calculator. 180 minus 26.4 is 153.6. So 153.6 degrees would go here. Because if I started measuring from this point here all the way around, that would be 156.4 degrees. And that is the degree of measurement that we use to tell us where we are. I'm sorry, I wrote that completely wrong. What was I thinking? I was looking at something weird. I was looking at 26.4. That's what I was doing. So 153.6 degrees. 153.6 degrees. This is your polar coordinate. That is what happens, or this is how we tell people where we're located on a coordinate system as a vector. Okay. So if you give me this, I know exactly where to find you from like a map or from a radar screen. That's what that is. So that's how I want you to type it in to the Jupyter. All of our problems are going to be using this method. All right. So if you don't know how to use this method, get with your senior lab partner. Your senior lab partner should know how to do this. If your senior lab partner does not know how to do this, you may come to me or you may go to another senior lab partner. I know that some of you have older siblings who know how to do this, who are very good at math, so you can use your siblings as well. But these are the main things you're going to do. You're going to use Pythagoras' theorem to find the hypotenuse. Then you're going to use SOHCAHTOA on your calculator to find the degree of measure of the right triangle wherever it is. Now, if your right triangle was over here, you wouldn't have to do this calculation because it would be measuring from here to here. So it's all about where it's located on the Cartesian coordinate system. Okay? All right, so that is a general overview of how to do polar coordinates. I'm not sure, I don't think the book explains it to you like that, but that is what we will be doing for this chapter. Hopefully there's not a lot of them. We'll see. If you have any other questions, please feel free to ask in class or message me. I'm good with that too.